Muted again. This is embarrassing, so let's test. Muted again. Okay, now it's working. Nice. So, sorry for the inconvenience. Okay, so let me start again. So today I'm going to make a bit of a shorter stream. The last streams have all been like 3 or 4 hours, which is actually way longer than I intended. And so today I'm going to feature on implementing a smaller feature which was requested in the discussion boards on Steam, and which I think is a pretty neat idea. And the idea is to make solar winds, or like cosmic winds which push stuff around, and these winds will have like a limited spatial effect, and they will push all kinds of stuff around, like ships, asteroids, particles, and I guess it should look rather neat, and it should add a little more stuff to experience in a typical level to the game. So this is what I'm going to do today. As I said, it's going to be probably a bit of a shorter stream, so I'm intending to get it done in like an hour, which is my rough estimate for this. Okay, so let's get started. Actually, I just fixed a bug which was sort of unfortunate. Maybe I can show you. So basically, I just had a bug which someone noticed me about, which was that some galaxies which are generated have parts which are not connected to the rest of the galaxy, which is sort of a very annoying bug. So this is what I fixed previously. And yeah, okay, so how am I going to do the effect? I guess I'm going to start with a nebula, because a nebula already is like a scenery object which exists in the world, and I'm going to build upon this. Okay, so let's do it. Let's call it Cosmic Wind. And let's add Cosmic Wind to the map generation process. So we have shops, gamblers, tech libs, artifacts, and so on. So for a start, I will make it, let's make a brief, let's make a small document so that we can see what we're going to do. So plan cosmic winds. Step 1 will be add the world. Step 2 will be add effect. And step 3 will be to test it. And finally deploy it to Steam. So this is planned for today. Yeah, that should work, I guess. Okay, nice. Okay, so first of all, let's add it to the map generation process. Let's call it Cosmic Wind. Okay, wait a second. Have you fixed aware of this bug yet? Let me see. Let me see what it is. Oh, I see. Oh, I see. There is a... Oh, thank you for pointing it out to me. Okay, let me show you. So apparently there's a translation bug here. Screen. Okay, so let me just fix this. Update. Splash screen. Tech lab. Shop upgrade. Upgrade. Upgrade disk. Okay. It's not okay. Upgrade disk should be. Oh yeah. Oh yeah. Okay. Thank you for pointing it out. It should be fixed in the next version. Okay, good. Good. Okay, so let's add cosmic winds. Let's add 5 for testing purposes. And in the map generation process, we need to take this map variable, and for each of these we will spawn a new cosmic wind. How did I call it? Cosmic wind, yeah. Cosmic wind. Okay. Nice. Okay, so first, so basically I've just copied it from the nebula class, so it will look and act like a nebula, which is of course not what we want. I guess for now I will just make it invisible. So I will replace the rendering function with an empty function. Also going to remove this thing, and for start I'm just going to add a small icon so that we know that it is working, and afterwards we can continue working on it. Okay, so render minimap is the part where the icon is actually rendered. So for now let's just take the nebula icon and go with it. And let's make it right. And let's give it a try. Okay. So this is not required, so I can remove it. It was lightning effect, which is not important. Okay. Okay, so basically, as a starting point, I just want to have it added to the map so that we can see that it works and progress from that point on. Okay, so this doesn't work for some reason. Cosmic wind requires what? Okay, we need world and we need other stuff. Okay, so I guess we need to add a world object for it to work. Okay. Okay, so yeah, I can do it later on. Okay. I guess the hardest part will be to implement the effect in a way that it works for particles, for ships and other stuff alike. But we can see how that works later on. Okay, so I guess it's working. I mean, I made it in a way so that it is rendered only on the minimap as like a nebula. And it seems to be working. Okay, nice. So next, I will replace this minimap graphic with a line. Line which is like an arrow which points in the direction of the wind I mean the direction in which the wind is facing. Okay, so actually this is not important, and actually we can use another base class, because the abstract scenery class is by default a class including a texture, which we do not need. So we can simplify it like this, and we can remove this stuff. Okay, so basically each wind has a position and it has a rotation. So the rotation determines the way it is the wind will be facing. Size is not important. Color is also not important, as you will only be able to see the effect based on how the particles are moving. And I guess icon is also not important at this point, even though maybe we want to keep this for now. Okay, so let's just make it white. And let's now change the way how it is rendered on the minimap. Okay, so previously it's just this texture, and we will change it by drawing a line. Okay, let me just figure out what is the easiest way to draw an arrow. Well, you can use the draw a line function. Don't quite remember how it works. I think it's called render line now. Line, okay. Oops. No, what's happening here? Okay, so we give it a vector, or we give it 2 points, which would also work. Okay, so basically we calculate 2 points and then we can draw a line around them, which would work, I guess. Okay, so let's do it. Okay, x1 is the position of the wind plus well, I guess it will be wrong initially anyway, so just try a sine of the rotation times size, and what will be the cosine of it? I guess it's exactly the other way around, right? Wait, let me just check. Sine of 0 is 0 and cosine of 0 is 1. Okay, so yeah, so the x is going to be the cosine and y is going to be the sine. Okay, this will be the first point of the line. The second point will be the same, but rotation plus 180 degrees. Okay, that should be it. Now we bind the right color and we render a line from x1, y1 to x2, y2. This is only the rendering for the minimap, but I guess it should work. I guess we need to divide the size by 2 to make it work. And I guess we also need a width for the line. So let's just try 10. I have no idea if it's working, if it's going to work as we expect, but let's try. Okay. If you want a really nice wind effect on ships, you could cast a bunch of parallel rays and apply force at each collision point. So you mean like implementing the wind by having a bunch of stuff which collides with the ships, if I understand you correctly. I guess it would look really nice. But I'm not quite sure what the performance impact would be, so I guess this will be a question which we can try later on when we come to the add effect point. Okay, so as we can see, it is rendered on the minimap. It is sort of huge, which is not intended, so we have to make it a bit smaller, and we also have to give it like an arrow shape. Okay, nice. So first of all, I guess white is a bit too bright, so instead let's make it like 50% opacity. And second, I want to make this smaller, so like half the size. And I also want to add like an arrowhead, which is going to be a bit awkward using this method, but yeah, as long as it's going to work, it'll be fine. Okay, so in order to make the arrowhead, let's add like pi divided by 32 or 16 or something to make it a little bit smaller. Yeah, this is probably going to look awful, but let's continue based on this. Whoops. Okay, so let's try it. JBoss has a raycast function which finds collision between bodies and rays. Okay. Yeah, apply impulse at point is what I already use for most of the forces in the game, like the propulsion and other stuff that is moving other stuff. Okay. I will check out the raycast function when we get to it. Okay, and now it's not in the test map, of course.
Begin mission. Factory detected.
This looks horrible. For some reason it's huge again, so I guess I messed up like X and Y. Yeah, I did. But other than that, it was actually sort of correct. I'm just going to go with it and make a minus sign here, so now it should be correctly pointing in each direction.
Begin mission. Module trigger detected.
Okay, okay, so now it is here. The icons are a bit smaller, but the arrowhead is far too small, so we have to make this much bigger. Oops. Here. Okay. So let's make this like divided by 4. Let's make this like times 8, just to get a feeling for it.
Begin mission.
Okay, this is actually okay. Okay, it's actually quite nice. Cool. Okay. Okay, so the first part is actually done. So next, let's go to the add effect part. Okay, so raycast, okay. Check it out. Polygon raycast. Okay.
Alright, so what's up, guys?
Bodies, polygons, type. This is basically pretty stupid, but I have no idea what the raycast does. What raycast? Okay, from point to point, draw a segment. Okay. Regarding your question about Steam, if you become a Steam partner, you can actually choose if you want to make a contract with them as a company or as an individual person. So actually, they do recommend if you're just one guy that you contract as an actual person. Which I guess makes sense for me. I mean, if you have like a team of people working on a project, I guess then it makes sense to also contract with Steam as this group of people. We are making a company, but there's actually nothing wrong with just doing it yourself. I'm not really sure if it makes a bigger difference. I guess maybe it does look a bit more professional if you have like a random company name, but I don't know. So yeah, basically, I contract with them as an individual. Okay, this looks good. Raycasting. Okay. Okay. Raycast callback. Raycast callback. Okay. See callback. Okay, so I understand. So you give it 2 points, and it tells you which objects intersect with the line. Okay, I see. I'm not really sure if it helps a lot, the raycasting, because the alternative would be just to, go through the list of all the world items and check which ones are in range. I guess this would also sort of work. So I guess for now I'm going to try the simpler approach, just because it is already what I do for like the shockwave effect, which is working sort of fine. I guess in general we can steal a lot from the shockwave, I just figured. Okay. Got a question. Having income as an individual incurs more tax in general. Yeah, the income tax in Germany is also sort of high, actually. I don't think it does make a big difference. Because even if you have like a company and you pay yourself a wage out of the company, you have to pay tax on this, and you have to pay tax on the profit the company makes. So I guess it doesn't really make a big difference. If you want to make like business with Steam, you do need to have like an ITIN, which is an international taxpayer identification number, which is specific to the US. And I think if you are thinking about going to Steam, you should, well in advance apply for such an ITIN, because it can take like a really long time, and if you have none, you will have to pay income tax both in the US and in Finland, which is of course very, very unfortunate. Okay, so if I would use the raycast method, it will cause rotation as well. Whether it causes rotation or not depends on the position at which I apply the force. And I think I can apply the force at the position of the stream, I think. I'll test it. I'm not totally sure yet. Okay, immune stuff, chart. Let's steal it for now from here. Execute. Okay, so this is not important. This is also not important. Okay, so we traverse through the list of all world items except the wind itself. So we have no list of immune objects, so we can skip this. And good question, should shots be affected by it or not? Well, why not, I guess. Let's try it. Other than that, we have distance from it. Okay. So for a start, let's try to see what this does. I guess it should work like the shockwave function. Okay, let's try it. Okay, I see a point. I see your point. It's actually really good. It's actually really good. So you could also make like, wow. So I guess using the rotation joint, you could make like a sailing ship, which could, wow. So if I implement it correctly, you could I could make like a mission where there are only solar winds and you have to navigate using like solar panels stuck on a rotation joint, which would be really great actually. Okay, you've convinced me. I'll try it. Well, I guess if I don't get anywhere, I will just quit without finishing it, honestly. Okay, so how is it done here? Raycast closest callback. Okay. Let's look at the API. Where is it? Where is it? It's actually really annoying just to find the API for it. Okay, I guess this is part of it. Index? No, yes, no, class. Wait a second, I actually have it on my computer somewhere. For exactly this reason. Okay, good. So what they were using is raycast clauses callback. Okay, multiple callback, any callback. Okay. Okay. Raycast closest callback. Yeah, this sounds right. And what are they doing? They are initting it. They're calling this raycast function. And if it is a hit, then they have like endpoint. What else do they have? And a normal. But how did they figure out which object it was colliding with? Okay, let's check it out. Raycast closest callback. Raycast callback. See world raycast. Okay. Report fixture. Okay, fixture is like an object in the world. Okay. Point, normal, fraction. It sounds reasonably simple. Okay. Wait, fixture. But wasn't it possible just to okay, raycast callback. Ah, I see, okay, I see. I guess this closest callback is a function which is also implemented here. So, or a class which is implemented here. Let's see. Yeah, it is. Okay, implements raycast callback. Hit point normal init, and here just delete it, and then okay. Perfect. Body, fixture, body, get body. Okay, let's do it. So first of all, let's delete all this crap. And let's generate a line. Wait, what was the argument for the word? vec2.1 and 0.2. Okay. Okay. Okay, let's see what the world object was called. Context filter. World with a line before it. Okay. So actually the normal world class is like world in my game, but if it has the line before it, it is the physical world object. Okay, so we need to define a callback next, and we need to have 2 points. Okay. So let's just do it like this. It should work for now. Point 1. And point 2. Okay, so now let's make the callback function. Actually, we could. Wait, what does it? Is it an interface? What is it? Raycast callback. Okay, it is an interface, so we could implement it ourselves. Okay, so let's do it. Implements raycast callback. So I guess we only need to implement this report fixture function and replace it with a function that moves stuff around. Yeah, it's actually even easier than I thought. Okay, void report fixture, and for now it will do nothing. Raycast, and we use this as the target for the function. Okay. I guess it will probably not compile because I haven't used this raycast stuff before. Let's test. Okay, so raycast callback is in JBox to the callbacks. Okay, let's do it. Okay, links to the callbacks, and what was it? Raycast callback. Okay, let's test it. Okay, it does not override abstract method to report fixture. Does it not? What does it need? Okay, it needs to return a float for some reason. I'm actually not sure what it would return. -1 to filter, 0 to terminate, fraction to clip the ray for closest hit, 1 to continue. It's a bit odd, okay. Missing return statement, okay. So what was it? 0 to terminate, -1 to filter, fraction to clip the ray for closest hit. 1 to continue, okay. Okay, so like you said, it's really about whether we want to have multiple stuff hit by the same ray, which I'm not sure about. Yeah, I guess I'll have to cast a lot of rays. We'll have to see about this. Okay, it's compiling. And actually, it's all which we have changed. So now we have to make it move around. Okay, so how do we do it? Contact filter. So how is it done? Okay, so we get the body and we have a body lookup function so that we can find the object, but maybe we don't even need it. Okay, so let's test it. It's gonna be really interesting if it works like this. Okay, so let's try it. Body is fixture get body, and what do we do? Well, we apply a force. Okay, impulse, point, strength, direction. Okay, apply linear impulse is probably what we want. Force, body, true. Apply linear impulse. Okay, let me just have a look. Apply linear impulse. Okay, and impulse point. An impulse at a point. The medium modifies the velocity. It also modifies the angular velocity if the point of application is not at the center of mass. This wakes up the body. Sounds about right. Sounds about right. Okay, so we have, I guess this is the point where the ray intercepts with the body, the fixture, and now just do body. So first of all, let's skip if body is null. We skip if fixture is null. The usual stuff. Body is null, and otherwise we apply linear impulse. What was it again? Impulse direction and point, okay. The world impulse vector at the point of application. Okay, point of application is easy because it is just this. And I guess the vector will be guess it should be the difference between these two guys. Okay, I guess optimization will come later, so for now let's do it like this. The direction is just x2 minus x1 and y2 minus y1. Okay. I'm interested to see if it will work like this. I guess it is probably it will probably work in the opposite direction, but I guess if it works at all, this is already pretty neat. Okay. Missing return statement and stuff. What? Okay. Okay. Okay, there's also another error, I think. So you want real laser weapons which hit instantly. You should check out the railgun. Actually, the railgun is almost instantly. Yeah, I cheated a little bit. It is sort of instantly. Yeah, it is. What is this guy's problem? Ah, okay, I see. The documentation which I have is not the same version which I'm compiling against, which is... I guess I should fix it at some point. But it has a new Boolean variable determining if it should wake up the body if it is sleeping. Okay.
Begin mission.
This will be really interesting.
Battery detected.
Okay, so let's try it. Okay, so it is about here. I guess I should have made like a little output, a debug output, so that we can figure out if it works. Oh!
Module selected.
I guess it is working. Yeah, and yo! Nice! It's working. It's only working across this line and it's working in the opposite direction. But it is working, which is great, actually. Nice. That was a lot easier than I expected. So now I only need to add more lines, more waycasts, and I need to optimize it a bit. Yay. And maybe make it a little less powerful than it is right now. Nice. Okay. So, first of all, okay, first of all, reverse the direction of it. Second, make this a little bit bigger. Third, let's reduce the power. I don't think we need the size anymore. Oh, we need it. Okay, we need it. Let's make it 0.1 for a start. Okay, we already reversed it here. So let's just multiply it by power. And I guess next we need to add more lines to it. Okay. Okay, first of all, let's test it again to see if the size and the power level make sense.
Begin mission. Module triggered.
Okay, so there should be wind just above here. And yay! That's really nice, actually. It's really nice. I guess we definitely need some particle effects, because otherwise it is very hard to figure out what's going on. Yeah, but I think there's definitely like tactical reasons you can use this for. Okay. So next, like this, here. Okay, I want to have multiple lines and I need to have some effects around it, because otherwise it is very hard to see. Are the wind arrows circle or rectangle? Yeah, it's a good question actually. I guess I'm going to make them rectangle, and it's all sort of unsatisfactory. I guess I can make them like a little oval in the sense that the outer lines will not be as long as the inner lines. I'll have to see. First of all, I want to add a particle field to it. So that there's stuff around the particle, around the cosmic wind, so that we can see the particle effect. It would be nice. Let's try it. Wait, no. Particle field. We need world base intensity, okay. World base intensity, whatever. And what do we do with it? We need to execute it. And we need to add it to the world, okay. Okay, so I guess we do not need to do anything else. I guess we do not even need to add it to the world because it does so itself. So I guess we can just create one and we're done. Let's test it. Yeah, I guess circling might really be a bit difficult. Okay, so now there should be particle fields surrounding the things. Yeah, here it is. But unfortunately they are not affected by the raycast, which we need to improve. So first of all, let's make it a little bit, give it more stuff. The unfortunate thing about the raycast approach is that it doesn't work with the particle fields at all. So for the particle fields we have to do the effect manually. Particle field shockwave. Particle force. A math lazy way to calculate the waypoints. We to recalculate intersection with the circle shape. Well, I'm not sure. Maybe this is even more complicated than actually doing the math yourself. I mean, you have to add like an object to the world and then remove it, and I'm always a bit scared about doing stuff like this, honestly. So yeah, the particle field. Oops. Field. Size does it have? Particle emitter. Okay, it has a fixed size, which we do not want. Emitter. Spread. Okay, so let's increase it. Okay, so first let's make it really big. And second. This is sort of annoying. Actually, it's not that hard. Actually, at least it should work. It should work. Okay. So what we will do? But how is it called? Particle fields. So we go through all the particle fields. And okay, I guess we can do it like this. Yeah. So now we have all the particles, and for each particle we check if it is in range, which is probably really slow. Let's see if it is too big of a performance impact. Okay. So range is force times 10. Okay. Make it like 20. Okay. So we can get the distance from px/py, which is correct. And I guess this is the strength of it. And this is the direction in which we will apply the force. Okay. So let's just use just use x1 minus x2. Y1 minus y2 times d. Okay, first of all, let's try times 10. I have no idea what the scaling needs to be on this. But I guess it has to scale with the distance, which it sort of should do. Let's try it. I guess in worst case we need to pre-calculate some of the stuff and also reduce the number of particles which are affected by it.
Begin mission.
Yay! We can sort of see the wind here. It's a bit very strong. It also seems to be very local. It seems to only affect this stuff. And the direction also seems to be incorrect. But beside the fact that everything is wrong, it sort of works. Okay. So I guess we need to increase the range a bit and decrease the power. Okay, so let's make it like 50. Let's make power divided by 10. Let's test it. Actually, yeah. What is happening here? Still seems to be very strong. That guy. Okay, it's still way too strong. So let's decrease it even further. And maybe let's make the range even bigger. Wait, this is like distance minus range. Okay, yeah. Let's try it. Wait, what is the size here? The size is 150. Okay, so let's just use the size. The circle shape has its own raycast method. Okay. Okay. Are you also using JBox2D for Battlefield Engineer? Because you seem to know a lot more about it than I do. Yeah, in fact. Cast ray against child shape. Huh. Interesting. Interesting.
Begin mission.
Whoa. What the hell? I guess it's a bit hard to see on the stream, but okay, here it seems to be working. It also seems okay. It seems to be working. It's still way too fast, so we have to make it much less strong again. Maybe like by a factor of 10. And I guess it also spreads out too much, and we have way too many particles, I think. I guess it will be a real performance issue if you do not improve it. Whoops. Did it crash? This bug again. Okay, faster physics. Okay. So let's see.
Begin mission. Enemy station detected.
Yeah, this is getting better. This is getting better actually. Yeah, it's still too fast, but it's much better than before. Okay. Okay, so let's make it even smaller, I guess. We'll see. And let's decrease the force even further to 0.02. Okay. What else do we need to do? Okay, we need to add lines along which the rays are cast. So now we have only one line. Okay. Okay, and I guess we need to pre-calculate it, because otherwise it would be very intense to calculate. Raycast line, and I'll be right back. I'll just a very brief break. Okay, so I'm back, and while I was away, I actually got an idea of how to make something like a circle without actually making a circle. So let me show you what I mean. So if this is the main ray, I could just calculate the 90-degree normal and then make a few lines like above and below. And I could just make the like more distant lines smaller, so it would have some kind of, it would look something like this. Okay, so I'm sort of happy with it. So how big should it be? Maybe like 5 units, 5 meters in the world. And how many lines should it be? Yeah, let's try it. Let's try a bit and see what will work and what will not work. Okay, what do we need? We need to have the P1 and P2 vectors, like here, and so you're not satisfied with my math lazy solution? Yeah, well, we'll see. I guess it will work out fine. So. We also need its strength, and we need an execute function, and we need a constructor for this stuff, and we need to initialize them when we start. So I mean, you already got your raycasting solution, so you can already be proud of your legacy in BossConstructor, which actually it really was sort of a very good suggestion, and yeah. Okay, so okay, so let's do it like this. So we start at -25. We go up to +25 in five increments, and for each we add a new ray. Rays add new raycast line with this distance as a parameter. Okay, and now this should take this distance as a parameter for the constructor, and we need to calculate these points based on this, which should not be too hard, I guess. So let's steal it from below. And okay, so we need to calculate like the normal direction, nx and ny, which is rotation plus pi divided by 2 times all this stuff. And I guess we do not even need this position. We can just, yeah, actually it's really simple. I think at least. Wait, is it? Okay. So we have like ray length, which is originally size divided by 4. which is 150 divided by 4. And we're also going to subtract the distance, so the outer line will be 25, so it will be 150, 24, 25, it will be sort of short, okay. Ray length, okay. Then we need to normalize the length of these vectors, okay. I guess we wouldn't need it if, okay, I guess we don't need it if we do it correctly, okay. So times d, okay, and we have it like this, and we just add the normal to it. And actually, that might be it. We'll see if it works later on. Do we have a 2D point rotation around world origin function? What does it even mean? Point rotation around world origin function. I'm not sure what you mean actually. Do you mean like for the OpenGL stuff, for the graphic stuff, or like for the physics simulation? Equals 1f minus rate. We need it. Okay, we need a little bit of a hack here because we cannot access the line outside. So here we need px, py. What do we need? We need the direction of the ray, which I guess we can also pre-calculate. Okay, yeah, we can. Okay, we can pre-calculate everything here. That's nice. x1 minus x2 times power and so on. Okay, do not even need to store it. We can just take like power was, what was it, 0.1f. okay, so just take 0.1f times 150 50 minus d, just make 50 minus d divided by 50. Okay, that should work. Okay. Oops. Okay. Actually, I'm like more like into testing it and trying it out myself. So things which I come up with are usually not as correct in a way, but I don't know. I guess I'm really just too lazy to do the math on this stuff. So I forgot that we need this stuff for the particles. So let's copy it and redo everything. Okay. Okay. Let's try again. Wait, what else do we have wrong? Residual method found for raycast cosmic wind line. Okay. Cosmic wind. Huh. Bit confused. Okay. So I guess we need to manually set this. Okay. Okay, I guess it makes sense. Let's try it. I guess in a way for these winds, it's not really clear why it would be a circle shape anyway. I mean, I have no idea how wind works in like like weather stuff. And
Begin mission.
okay.
Enemy station detected.
So let's try it. Okay, so we have a wind right here. Let's see if we can just... So it doesn't seem to affect me now. No. Also not. So why not? Okay, so for some reason it's not working. That's unfortunate, okay. Okay, so either we are not intersecting with it, or what else could it be? Apply linear impulse. Good line. The direction is wrong. I'm not sure. Okay, let's try different things. First of all, okay, yeah. So first of all, let's eliminate the normal stuff, and let's eliminate the strength stuff. So let's just make it like 10, 0 as a direction, and let's see if it works from there on. Oops. Yeah.
Begin mission.
Okay. So there should be a wind right here. Let's see if we cross it. And it doesn't work again. Okay. Okay, so I guess we have to add some debug output. Okay. Okay, first of all, let's see how many ways there are. Then, let's see whenever we have like an intersection here, let's print it out. Okay. Okay. I guess it will probably be a bit hard to tell from the debug output what's going on, but at least we could see what's happening. Oh, you're right. Actually, I could. Okay, that's actually a very good idea. It's just let's just draw it. Yeah, it's actually a really good idea. You can just add it here. So for every ray, render line, ray p1x, ray p1y, and the same for the second one. Yeah, done. Nice. Sweet. So that should tell us if we have any major problems here. Okay. I guess I should have disabled the other output, but let's try it.
Begin mission. Module trader detected.
Ah, okay, so here we have our problem. It's all in the top left corner, because apparently what have I done? X1 px py. Ah, I see. I guess. Yeah, okay. These rays are created before the object is added to the world, and hence, yeah, okay, nice. Yeah, you are right. Visual debugging is the best debugging. Okay. Okay, so instead of initializing these rays right at the start, we need to initialize it when it is first rendered, so first executed, I mean. So if it is not initted, set initted to true, and here we create the rays. Okay, nice. So this was working. And what else do we need? So I guess we can put it back to how it was. And just for the sake of this exercise, let's disable the arrows so that we can see only the ways which are used.
Begin mission.
Well, okay, I guess I have to use like yeah, okay, I cannot just subtract it if it can become negative, okay? Other than that, whoops, let's try it.
Module connected.
nice. It's working, I guess. Okay, I need to fix the length of the lines. And I guess I need to tone down the effect a little bit. Nice areas. Okay, so instead of this, let's make the absolute value of the distance. Okay. I guess maybe we can make it a little bit longer, like divide it by 3. Let's test it.
Begin mission.
Okay.
Factory detected.
I guess this is sort of like a good size for the wind effect, I think. So, gently being pushed around, okay. What's going on in this level? What the hell? I guess we can make it even bigger. Here it is. Okay. Actually, it has a really nice effect, I think. And we also need to make the absolute function here in the bottom when we, give this point, when we determine the strength of the effect. Yeah, let's try it. Let's make it even bigger. Let's make it 150 divided by 2. And let's add lines up to minus 45 and plus 45. So now we should have close to 20 lines. So I guess I would take like cosmic winds as a reference, but
Begin mission.
yeah, I guess we are pretty close to like a hexagon. Okay. So okay. What the hell?
Module collected.
So this was not very successful. Let's try it again.
Begin mission. Module trader detected.
Let's see. Oops. Okay. So the effect should push me back now. Or push me to the right. To the left rather. Okay. I guess the winds are very strong. I guess like too strong. Okay. Yeah. What the hell? I guess I shouldn't make it affect these shots because they have only very small collision areas and it's looks a little bit buggy.
Module collected.
It does add a lot of drama to it, I have to say. Okay. So, first of all, I'm going to remove the effect for asteroids. No, for shots. How do I do it actually? Okay, I have to use the lookup table to figure out if it is a shot. So I have like a global body lookup table which links the physical bodies to the objects in my world, which is unfortunately the only way to figure out what it is. So if WIP is not 0, not null, and WIP is instance of an abstract shot, then we continue. Yeah, as far as I know, if I return 1 from this function, it will just continue. While if I return 0, it will stop at this point. This is how I understand this callback function to work. Okay, so let's remove the debug output and let's reduce the effect by like 50%. I guess you could also give them different strength. Okay. And I'm also going to remove the debug output and enable the original error output. Maybe apply the force to the particles instead? You mean in order to... you mean the particles of the projectiles, I guess.
Begin mission. Enemy station detected.
Okay. Okay, so let's try this wind. We also need to try like a huge sailing ship next. Yep. It works, okay. Is it strong enough for me to push against it? Well, not at the center, I guess. Whoa. Okay. So how can we use it tactically? I mean, the other ships are going to have difficulties following me if I'm there. Okay. I guess the problem with the projectiles is that they each have a very small circle collision radius. So they're using the circle shape fixture. And I have to make many more rays, I think, in order for them to work. Which is... I have no idea actually what the performance impact would be. And other than that, the shots usually have a very, very small mass. So they are really heavily affected by the wind. So I guess I have to make them heavier or make... I guess in the real world, the strength of the effect would depend on the surface area which is affected by the wind. But since we only have these rays, it will pretty much be the same, regardless of... what was I saying? Regardless of whether it is big or not, you know. Okay. Okay, so let's try something like this. Guess it doesn't quite fit like this. Okay, this should be like a really aerodynamic ship, I think. So in theory, we should be able to ride these winds really well with it.
Module trader detected.
Oh, by the way, are asteroids affected too? Oops. Yeah, I guess they are. which is nice. Okay, so now let's get on, and it's a line. Yeah, yeah, ooh, nice. Let's see if we can fly against it. It's actually working really nice. It's very hard to navigate when you are affected by the wind, but it's obviously how it would be. So let's try. Okay, let's try something else. Let's try if we can use it to increase our maximum speed. Oops, not here. So I guess we want to have a really fast ship, and we can. I mean, previously it didn't really make a difference to make it aerodynamic. So now we can try to build it in a way that we can glide along the wind. Actually, I really want to see someone make a ship which uses only the rotational joint to navigate using the winds. But I guess I need to have many more cosmic winds in order for this to work. Whatever. Okay. So there's the wind right here. And this is not very good. This is not going to end well. Okay, nice. So, I guess this is sort of done. Oops. Well, how many of these should be in a typical sector? I'm not sure. I guess maybe like 2 to 5 or so. Well, I can try it. And I guess I should also add these to the skirmish mode, which I made last week. Yeah, I guess the strength feels about right. It does have a significant impact on your ship, even on compact ships like this. And I guess you can sort of implement it into your strategy by making bigger ships, or wider ships, or lighter and wider ships. Ooh. Okay, nice. Okay, so now finally let me set the number here. Okay, so this is like between 0 and 2. Okay, so let's make it between 0 and 6, I guess. I guess 6 would be nice. Oh, okay. -1 is return. Okay, okay. Okay, so I'll change it then. Okay, good. Good. Okay, so nice. It still took me 2 hours to do it, but it's done, I guess. We can make a complete build, a clean build, so that the translation issue I had is also fixed. And then I can just push it to Steam, which is nice. Okay. Difference between -1 and 1. That's not it. Oh. Okay. Still working. Okay, so let's deploy it, and finally let's make a brief description. What am I doing here? Okay. So what did I do? Fixed sharding effect of the command center, fixed the bug causing, what was it? Potentially causing parts of the galaxy to be disconnected, and finally added solar winds from the live stream. Okay, here we go. Okay, so I guess I'm pretty much done for today. So I guess the stream length felt about right for me. So I guess this is sort of the scope of stuff I will do in future live streams, because I think the 3 or 4 hour live streams were a bit too exhausting in the end. So while I'm deploying it, let's just, if you have questions, feel free to ask them now. Yeah, other than that, I will be back next week, adding some more stuff to the game. And yeah, thank you very much for watching. Yeah, Tommy, if you are going to do another stream, please let me know. I'd like to watch it. And yeah, other than that, have a good day, have a good week, and yeah, thanks for watching. Bye bye.